Ducatis were often associated with their big powerful V-twin engines, and it used to be one of their USPs. But with the introduction of the Diavel V4, it seems that Ducati is slowly replacing the big V-twins in favor of their new V4 engine. But why? That's what we are going to explore in this video. With 14 championship titles and 300 race wins, Ducati is the most successful team in the World Superbike Championship. Their legendary 90-degree V-twins, or otherwise known as the L-twin, had a huge role in those achievements. Those big L-twins possesses a major advantage over its inline-4 competitors. The 90-degree V-twin is mechanically better balanced than an inline-4, which often requires a balanced shaft. Let me elaborate on that statement a little bit further. In a traditional inline-4 engine with 180-degree crank, all the pistons stop at the top or bottom dead center in every 180 degrees of the rotation. Suppose you are on a racetrack and is about to exit a corner. Your motorcycle is fully leaned over. The traction available at that time is at its minimum. Now, let's just say that the engine is revving at 10,000 RPM. At that instance, the pistons are transmitting a huge amount of energy into the crankshaft at about 333 times per second. Now, you open the throttle to exit the corner, and there will be a change in the rate at which the energy is transferred from the piston to the crankshaft. The crankshaft will react to this change with an abrupt RPM fluctuation. In a straight line, you won't notice this RPM fluctuation, but at full lean, where the traction available is at its minimum, the sudden RPM fluctuation will disturb the traction and may result in a high side crash. So you will have to be careful when opening the throttle at the corner exit. In racing, it will cost precious lap time. That's where the L-twin has its advantage with its superior mechanical balance. In case of a 90-degree V-twin, when one piston is at its maximum velocity, the other piston is stopped, and 180 degrees later, the situation is reversed. Hence, the pistons are trading energy not with crankshaft but with each other, giving it a much better mechanical balance than the inline-4 engines. As a result, whenever you apply more throttle, the change in rotating speed of the crankshaft happens much more progressively and smoothly. This allows the rider to open the throttle much earlier without disturbing the traction available at the rear tire. But as the technology advanced, the inline-4 started to manage the traction better at the rear wheel, and the advantage started to diminish. And in a desperate attempt to maintain their dominance, Ducati allegedly lobbied with FIM to let their bikes with bigger capacity engines to compete, and threatened to leave the sport otherwise. They caved to the Ducati's demand, but set an RPM limit not to piss off other participants. It worked out for a while, as Ducati was able to achieve 2 titles during 2008 and 2011 seasons with their 1098. But that was the last time Ducati won a WSBK title with a V-twin engine-powered motorcycle. The gorgeous Panigale 1199 that came after the 1098 would end up becoming the only flagship Ducati unable to win a single World Superbike Championship. This high-capacity trick was also causing some problems for Ducati outside the racetracks too. With a 200cc displacement advantage, the Panigale 1199 was brutally fast and equally capable both at the track and the road, even though it proved to be quite a handful of a motorcycle to ride at its limit. The problem here wasn't the performance, it was the emission compliance. Out of all Ducati V-twins, the Panigale 1299's Super Quattro L-twin was the only engine that didn't pass the Euro 4 emission regulations. This engine in the Panigale 1299 started its life as a 1200cc unit in the Panigale 1199, which was already an all-squared engine. Ducati then bought it out again to make the Panigale 1299, increasing the engine capacity close to 1.3 liters, 1285cc to be exact. And that presents a problem. Because as the bore-to-stroke ratio becomes larger, the combustion tends to slow down as the tight chamber dampens the flame speed, causing a less efficient combustion process resulting in higher pollution. So now Ducati had 2 choices. One is to spend millions of dollars in an attempt to make the monstrous V-twin Euro 4 compliant, and the second is to go back to the drawing board and create a completely new engine from ground up. Ducati chose the second one and built the all-new V4 engine, which we now know as the Desmos Ricci's Stradale V4. Thanks to this new platform and the epic performance by Alvaro Bautista, Ducati was finally able to claim a World Superbike Championship title after a decade.